Assalamualaikum and hello. My name is Noliana Izzati binti Zulkifli and my matrix number is 16DKA19F2046. Beam calculation. Project. The beam shown in figure 1 is fully restrained along its length. Design the beam FE430 steel S275. From analysis, VED is 289.9 kN. MED is 241.6 kN and W is 50 kN. Tri-section 457 times 191 times 82 UB. Page 2 for beam calculations. Based on clause 6.2.6, page 50, shear force resistance checking. The checking must satisfy VED divided by VCRG is less than 1.0. VCRG equal to VPLRG. VPLRG equal to AV times by Fy divided by 3 root 3 divided by MO. Based on clause 6.2.6 page 50, AV equal to A minus 2 times B times TF plus TW plus 2R times TF. The result is 4763.2 mm. VPLRG equal to 756.26 Newton. VED divided by VCRG is less than 1.0, which is the result is okay. Shear buckling resistance checking for web. HW divided by TW is greater than 72 times E divided by N. HW equal to 428 meter. HW divided by TW is 428 divided by 9.9. The result is 43.23. 72 times E divided by N. The result is 66.24 greater than 43.22. The result is not required. Since HW divided by TW less than 72 times E divided by N, the shear buckling resistance checking for web is not required.
Reference clause 6.2.5 page 50 bending moment resistance checking over the checking must satisfy MED over MERD less than equals to 1.0 for class 1 cross section. MERD equals to MP1, FY over Y0 equals to 799 times 10 square times 275 over 1 times 10 power of 6 equals to 21.97 kilo nanometer. Reference clause 6.3.1 page 56. Buckling resistance checking. NED over NB, RD less than equals to 1.0. NB, RD equals to A6Y over YM1. Therefore, buckling curves measure for Y minus Y axis. Y equals to 1 over Y plus square root Y square equals to Y square. Y equals to 0.5 bracket 1 plus theta bracket minus 0.2 close bracket plus close bracket equals to square root AFY over NER equals to square root 90.4 times 10 square times 275 over 706 times 10 power of 3 equals to 1.88. Y equals to 0.5 bracket 1 plus 0.21 bracket 1.88 minus 0.2 plus 1.88 square close bracket equals to 2.44. Y equals to 1 over 2.44 plus square root 2.44 square plus 1.88 square equals to 0.181 less than equals to 1.0. Okay. Output okay.
Column calculations. Project. The column shown in Figure 1 is unrestrained along its length. Design the column in FE 430 steel S275. From analysis, NED equal to 1000 kN. Try section 203 times 203 times 71 UC. Based on the table of dimensions and cross-section properties, the following are the dimensions and properties of sections. H equal to 215.8, B equal to 206.4, TW equal to 10, TF equal to 17.3, R equal to 10.2, D equal to 160.8, CF divided by TF is 5.09, CW divided by TW equal to 16.1, WPL divided by Y is 799, A equal to 90.4. Based on table 3.1 page 26, material properties, steel grade, Fe 430 S275, E smaller than 40 mm, Fy equal to 275, while Fu is 430. Based on table 5.2 page 43, classification of section, flange subject to compression, Cf divided by Tf equal to 5.09, smaller than 8.28. Flange is in class 1, web subject to bending, Cw divided by Tw equal to 16.1, smaller than 30.36. The result is okay. Column calculation, page 2. Based on clause 6.3.1.3 on page 59, column slenderness, Ly equal to 6100 mm, LCR equal to 1.01 I, E equal to 0.92. The result for Y is 7.7, while for Z is 13.3. Based on clause 6.2.4 on page 49, compression resistance checking. The checking must satisfy NED divided by NCRD less than 1.0. NCRD equal to 2,486 kilonewton. NED is 1,000 kilonewton. So 1,000 divided by 2,486 lower than 1.0. 0.402 less than 1.0. The result is okay.
Reference clause 6.2.5 page 50. Bending moment resistance checking over the checking must satisfy MED over MERD less than equals to 1.0 for class 1 cross section. MERD equals to MP1 FY over Y0 equals to 799 times 10 square times 275 over 1 times 10 power of 6 equals to 21.97 kilo nanometer. Reference clause 6.3.1 page 56. Buckling resistance checking NED over NB comma RD less than equals to 1.0. NB comma RD equals to A6Y over YM1. Therefore, buckling curves measure for Y minus Y axis. Y equals to 1 over Y plus square root Y square equals to Y square. Y equals to 0.5 bracket 1 plus theta bracket minus 0.2 close bracket plus close bracket equals to square root AFY over NER equals to square root 90.4 times 10 square times 275 over 706 times 10 power of 3 equals to 1.88. Y equals to 0.5 bracket 1 plus 0.21 bracket 1.88 minus 0.2 plus 1.88 square close bracket equals to 2.44. Y equals to 1 over 2.44 plus square root 2.44 square plus 1.88 square equals to 0.181 less than equals to 1.0. Okay. Output okay. The calculation, therefore buckling curves minor equals to x minus x axis equals to 1 over 0 plus square root 0 square equals to a square equals to 0.5 1 plus theta minus 0.2 plus square equals to square root AFY over NER equals to 90.4 times equals to square root 90.4 times 10 square times 275 over 246 times 10 power of 3 equals to 3.18 equals to 0.5 bracket 1 plus 0.34 bracket 3.18 minus 0.2 plus 3.18 square equals to 6.05. 1 over 6.05 plus square root 6.05 square minus 3.18 square equals to 0.09 less than equals to 1.0. Okay. Output okay. Reference table 4.1. Calculation. Cover plate use should be less than 150 millimeter. Given Fw, Ad equals to 400 kilo nano, try cover plate 125 millimeter, try size 800 millimeter fillet weld. Throat thickness A equals to 0.7, S equals to 0.7 equals to 5.6 millimeter. Solution. Design shear strength of welt FVW, D equals to FU over BUYM square root 3. FU equals to 410 nano over millimeter square. BW equals to 0.85. YMZ equals to 1.25. FVW, D equals to 410 over 0.85 times 1.25 times square root 3 equals to 223 nano over millimeter square. The design resistance of the weld per unit length Fw, Rd equals to Fvw, D dot A. 223 times 5.6 equals to 1248 nano over millimeter equals to 1.25 kilo nano over millimeter. Minimum length required 400 slash 1.25 equals to 3200 millimeter. The required length equals to 320 times 320 plus 28 plus 28 equals to 352. Total resistance of weld equals to 1.25 300 equals to 450 kilo nano, more than 800 kilo nano. Okay. Output okay.